In section 1.6 of college algebra, we're going to be looking at other types of equations and applications. The first type of equation we're going to be looking at is a rational equation. A rational equation is one that has rational expressions for one or more of the terms. So here's an example of a rational equation. They usually are going to have variables in the denominator. So here's going to be our steps. The first thing we're going to want to do is, let's see, I'm going to write solve a rational equation. These are going to be steps. So they stand out later. First thing we're going to do is factor the denominators and then list any excluded, which is sometimes also called a restricted value. We do that by setting the denominator not equal to 0. Then we will multiply each term by the LCD over 1, which is going to clear the fractions. So that's going to take it from an equation that has variables in the denominator to an equation that doesn't have variables in the denominator. Then we solve the equation to find potential or proposed solutions. And then we are going to check for extraneous solutions by looking back at our excluded values. So let's look at this first problem here. The denominators are already factored. In fact, I'm going to go ahead and put this one over 1, that term. So my denominators are 3 and x minus 1 and 1. So that LCD, none of those are the same, so the LCD will be 3 times x minus 1. I won't usually include the times 1 because it doesn't really do much for me. So I'm going to take each term and I'm going to multiply it by 3 times x minus 1 over 1. So I'm going to give myself a little bit more space. 3x minus 1 over 3 times 3 times x minus 1 over 1 minus 3 times x minus 1 over 1 times 2x over x minus 1 equals 3 times x minus 1 over 1 times x over 1. Now, I will usually go ahead and put the numerators in parentheses as well, just to keep things to make sure I remember that they exist. And then I'm going to go ahead and cancel out any common factors from the numerator and denominator. So in this first term here, I have a 3 and a 3. So I'll cross those out, and that's going to leave me with x minus 1 times 3x minus 1. In this second chunk here, I have an x minus 1 in common. So keep in mind that this x minus 1 is also in parentheses, which is what allows me to cross off x minus 1 and x minus 1. So then the second term, I have to remember my subtraction sign, 3 times 2x. And then on the right side, nothing is going to cancel, so I'm going to have 3 times x minus 1 times x. Okay. So I have to solve this equation, which makes me have to use a lot of my algebra skills from the past. I'm going to need to box multiply x minus 1 times 3x minus 1. These I'll just multiply regular. And this 3 times x minus 1 times x, I'm going to think about that like in a different order. I'm going to put the 3 next to the x and then the x minus 1, so I can just distribute that 3x into the x minus 1. So if I, off to the side, box multiply x minus 1 times 3x minus 1, I'll have 3x squared minus 4x plus 1. So I've got 3x squared minus 4x plus 1, negative 3 times 2x minus 6x, and then distribute that 3x, so I get 3x squared minus 3x. Now, this right now is a quadratic equation because it has a degree of 2, but I notice that when I start moving terms around, by subtracting the 3x squared, that 3x squared is going to cancel on both sides. So it's not a quadratic equation anymore. It's actually going to be a linear equation. So I'm going to go ahead and combine these like terms to get negative 10x plus 1 equals negative 3x after those quadratic terms dropped out. Now it's just a plain old linear equation. So I will move all my variables to one side, leave my constant term on the other. So I get 1 equals 7x, divide both sides by 7, and I get x equals 1/7. Do you guys notice what I forgot to do at the beginning of this problem? It's like the second step. List the excluded values by setting the denominators not equal to 0. So I'm going to go back up and do that now, and I'll try not to forget it on my next problem. So here, if I look at this denominator of 3, it does not make sense to say 3 is not equal to 0. So if you just have a number in your denominator, you can ignore that term because it's not going to give you any domain restrictions. But this x minus 1, I set that not equal to 0, solve that for x, and I get x cannot equal 1. And this denominator I will ignore as well. So here's my excluded value. I say x cannot equal 1. But when I solved, I got x equals 1/7. Since x equals 1/7 is not a restricted value, then this is the solution to that equation. Let's look at this one. X over x minus 2 equals 2 over x minus 2 plus 2. So again, I'll go ahead and put my term that doesn't have a denominator over 1. And then the LCD here, since both of these denominators are the same and this denominator is 1, the LCD will just be x minus 2. So I'm going to multiply, excuse me, I'm going to multiply each term times x minus 2 over 1. So I'm going to move down here a little bit. X minus 2 over 1 times my original term of x over x minus 2 equals x minus 2 over 1 times the original term 2 over x minus 2 plus x minus 2 over 1 times the original term 2 over 1. And let's see what cancels. In this chunk, the x minus 2 cancels with the x minus 2, because remember that's in parentheses. So cross those off, and then that's going to give me just x in that spot. In the next little chunk here, x minus 2 and x minus 2 again cancel. So I'm left with 2. And then plus, in this chunk, nothing cancels. So I have x minus 2 times 2. Then to solve this equation, my next move will be to distribute that 2. So I have x equals 2 plus 2x minus 4. And it's a linear equation again, so I'll go ahead and solve for x by combining these like terms and subtracting the 2x to the other side. I'm going to do that all in one step. So x minus 2x, I get negative x equals 2 minus 4 is negative 2. Go ahead and divide both sides by negative 1 to get x by itself, and I get x equals 2. Guess what, guys? I forgot to check the extraneous value, or the excluded values again, but it's not too late. We'll go up to the denominators, and I will set each denominator not equal to 0. So I get x minus 2 cannot equal 0, which gives me the excluded or restricted value that x is not allowed to equal 2. This one here is the same. X cannot equal 2. And this one here I ignore because it didn't have a variable. So my restriction is that x cannot equal 2. And when I solved, I got x equals 2. So I have to ignore this solution because it was my excluded value. So I cross that out. It's actually called an extraneous solution. And since that was the only solution I found, the actual answer to this is the empty set or no solution. Okay, let's see if I do better on the next page. Solving rational equations that lead to quadratic equations. Ooh, these will be more exciting. So here I have 3x plus 2 over x minus 2 plus 1 over x equals negative 2 over x squared minus 2x. So I'm going to remember my steps. The first thing I'm going to do is factor the denominators. So that might include box factoring. That might include finding a GCF. In this case, the x minus 2 is already factored. The x is already factored. And the x squared minus 2x would factor to give me GCF of x, which leaves x minus 2 in that denominator. So after I factor, I have 3x plus 2 over x minus 2 plus, I'm going to leave myself space so that I can multiply by my LCDs. 1 over x equals negative 2 over x times x minus 2. Let's go ahead and find that LCD. So if I look at my denominators, I have one denominator that is x minus 2. I have another denominator that is x. And this denominator was x times x minus 2. So the LCD is going to have x minus 2 times x. So I'm actually going to multiply each term by x minus 2 times x. Over 1 times x minus 2 times x over 1 times x minus 2 times x over 1. Before I do my canceling, I'm actually going to remember to find my excluded values. And I do that by setting the denominators not equal to 0. So this one tells me that x cannot equal 2. This one tells me that x cannot equal 0. And this one would give me both of those values. X cannot equal 0 from this part. X cannot equal 2 from that part. So I'm not going to write them down because they're just repeats. So I have two excluded values, 0 and 2. All right, now let's go ahead and cancel those common factors. So one from the numerator, one from the denominator. In this first piece, I see I have an x minus 2 in the denominator and x minus 2 in the numerator. So I'm going to be left with the x here times, remember that this is in parentheses, so I'm going to have x times 3x plus 2. Then my plus sign. In the second chunk, this x down here cancels with this x up here, and I have x minus 2 times 1, and then equals, on this chunk, the x here cancels with the x here, and the x minus 2 also cancels with the x minus 2. So I have equals regular old negative 2. My next job is just to solve this equation. So I'm going to start by going ahead and distributing this x into these parentheses. So I get 3x squared plus 2x. I mean, I guess distribute the 1 here, but that's still just going to give you plus x minus 2, and then equals negative 2. So this gives us a quadratic equation. And to solve a quadratic equation, I have a few options. When there's a quadratic equation, we studied those in section 1.4. Wow, equation, there we go, fixed it. We can sometimes factor. We can sometimes use the square root method, which just means take the square root of both sides. We could complete the square. Or we could use the quadratic formula. The way that you solve these is going to be really up to you. So if I solve one a different way than the way you solve it, we should still get the same answer, and that's okay. So it's a quadratic equation. I will probably either factor it or use the quadratic formula. So I'm going to go ahead and make this equal 0 by adding 2 to both sides and then combining these like terms. So actually when I add 2 to both sides, that cancels out and I get 3x squared plus 3x equals 0. So if I start factoring, then what I want to do is look for a GCF, which is 3x. So when I divide 3x squared by 3x, I'm left with x. When I divide by 3x, I'm left with 1. So this factors to give me 3x times x plus 1. When we solve by factoring, then we take each part that contains a variable, set it equal to 0. So I've got 3x equals 0, which I will divide both sides by 3 and get the solution x equals 0. I have x plus 1 equals 0, so I will subtract 1 from both sides and I get x equals -1. Now these are what we call the proposed solutions. They may work, they may not work. We have to check against the restrictions that we had at the top or exclusions. So if I check up here, we found that x cannot equal 2, x cannot equal 0. So on my proposed solutions where I see x equals 0, I have to cross that one off because it was one of my excluded values. And then the only one that works is x equals -1. How about this guy? -4x over x minus 1 plus 4 over x plus 1 equals -8 over x squared minus 1. Now, I'm going to start by factoring the denominators. And I'll tell you that this denominator has a pretty recognizable pattern. It is difference of squares. And you actually will see this a lot in these kinds of problems, these rational equations. You'll see it a lot. The difference of squares is the one that factors into the 2 parentheses that are f plus L, f minus L. And you see it a lot, so it's worth kind of recognizing. So x squared minus 1 is going to factor into x plus 1 times x minus 1. All right, let's get our excluded values. Set this denominator not equal to 0. I get x is not allowed to equal 1. Set this denominator not equal to 0. I get x is not allowed to equal -1. This denominator would be repeats, so I'm not going to mess with it. What I am going to do is figure out what the LCD is and then multiply each term by the LCD over 1. So for my LCD, I have x minus 1 for one denominator. I have x plus 1 for another. And then my third denominator has x plus 1 times x minus 1. So we should be able to tell that our LCD will have x minus 1 and x plus 1. So that would be our LCD. So I'm going to multiply each term by that LCD over 1. I am kind of running out of space here, so I am just going to move all the way down to here. So I will take x minus 1 times x plus 1 over 1 times the first term, which was -4x over x minus 1, plus the LCD over 1, so So x minus 1 times x plus 1 over 1 times my second term, 4 over x plus 1. And then equals the LCD over 1 times the thing on the other side, which was negative 8 over x plus 1, x minus 1, because I do want to use the factored form of that denominator. And then I'm going to cancel what I can and see what's left. So in my first piece, put that guy in parentheses and that guy in parentheses. I can cancel off x minus 1 with x minus 1. So I'm left with x plus 1 times negative 4x. And then I have a plus sign. In that second chunk, I can cross off x plus 1 and x plus 1. So I'm left with x minus 1 times 4. And then on the right side, I can cross off x plus 1 and x minus 1. So I'm left with equals negative 8. Then I need to go ahead and solve this equation. So I will distribute negative 4x to both of those terms, which gives me negative 4x squared minus 4x. I will distribute 4 to both of those terms, which gives me plus 4x minus 4. And then on this side I have negative 8. This is another quadratic equation, so here are my methods to solve. Let's see. If I combine these two like terms, I get negative 4x squared minus 4 equals negative 8. Now this would be a good one to solve by the square root method, because in the square root method, you have to just have a squared term and a plain number term. But I could also solve it by factoring or quadratic formula. If I add this 8 over to the left side, I get negative 4x squared plus 4 equals 0. If I wanted to do this by factoring, I could take out a GCF of negative 4. So that would give me negative 4 and then x squared minus 1 equals 0. And then I could factor this. Well, guess what I recognize? That is another difference of squares. So if I factor it, I get x plus 1 times x minus 1 equals 0, which gives me two answers. X equals negative 1, x equals 1. I don't do anything with this negative 4 out front because it doesn't have a variable. So here are my proposed solutions, which if I check against my restrictions, I see both of those are not okay. X can't equal 1, x can't equal negative 1. So both of those are excluded values, which means, remember, we have no solution. Let's just go back to this little step here. If you wanted to solve this by square root method, then I will show you kind of that alternate method. If we had negative 4x squared plus 4 equals 0. To solve by square root method, I need to isolate the squared thing. So I will maybe subtract 4 from both sides, which gives me negative 4x squared equals negative 4. Then divide both sides by negative 4 so that the x squared is by itself. So I'm getting x squared equals 1. At that point, I take the square root of both sides, which leaves me x on the left side. And remember that when you take the square root of both sides, you have to use plus or minus on the number side. So I'm going to get x equals plus or minus 1, which is just what we got when we factored as well. So you could do Really any method that works to solve these quadratic equations is fine. An application of these rational expressions and rational equations is what we call a working together problem or a work rate problem. For a simple working together problem, you can just use this formula. We take 1 over the time it takes someone working alone plus 1 over the time it takes person B alone is equal to 1 over the time it would take them to finish the job together. There are more complicated ways to set these problems up, but really we're going to be doing some pretty straightforward problems. So this formula is going to work out for us. Here we have Lisa and Keith are raking the leaves in their backyard. Working alone, Lisa can rake the leaves in 5 hours, and Keith can rake them in 4 hours. How long would it take them to rake the leaves working together? So I'm just going to take 1 over Lisa's time working alone plus 1 over Keith's time working alone is going to equal 1 over the time it would take them working together. Well, we don't know how long it would take them working together. So that's our x value. So x is the time that it takes them working together. In my formula then, I put 1 over Lisa's time, so 1 over 5, plus 1 over Keith's time, 1 over 4, is equal to 1 over x, which is the time it would take them together. Now this is one of those rational equations that I would like to solve by multiplying by the LCD over 1. So my LCD, one of my denominators is 5. One of my denominators is 4. One of my denominators is x. So my LCD is going to have 5 times 4 times x, or 20x. So I'm going to multiply each term by 20x over 1, or 5 times 4 times x over 1. Take your pick. If you do 5 times 4 times x over 1, then you can really quickly see what's going to cancel and what's going to stay. Just remember to do each term. Don't leave any of them off. Okay. All right, and then we are going to cancel what we can. So I've got 5 that can cancel here, which is going to leave me 4 times x times 1. So 4x plus, in this second piece, the 4's are going to cancel, which leaves me 5 times x times 1, or 5x. And then on this side, the x's are going to cancel, which leaves me 5 times 4 times 1, which is 20. Now this equation is really simple to solve. It's just a linear equation. I will combine those like terms, which gives me 9x equals 20. Divide both sides by 9, and I get x equals 20 over 9. Since I was measuring these in hours, then it's going to be 20 over 9 hours. Sometimes they like you to put those in mixed numbers. So 20 over 9 hours would be like 2 hours. 2 hours would be 18 over 9. So 2 hours. And then I would have 2/9 left over. So 2 and 2/9 hours. Okay, how about this printer? One printer can do a job twice as fast as another. Working together, both printers can do the job in 2 hours. How long would it take each printer working alone to do the job? So I'm going to have that simple working together. So 1 over the first printer, its time alone, plus 1 over the second printer is going to be equal to 1 over the time it takes them together. So what we know about these printers, well, we don't know how long they're going to take, but we do know that one printer can do a job twice as fast as another. So if I make one of my printers X, so let's say I make my first printer take X amount of time, then the other one can do that twice as fast. So if I do X and then twice as fast means it takes half as long. So the other one would be 0.5X. And then working together is 2 hours. So I could do it like that. I could say X and 0.5X, or I could say if it takes my 0.5X, let's just do it this way because that's how I have it set up. I don't want to confuse anybody. So 1 over the first printer, 1 over X, plus 1 over the second printer, so it takes half as long, equals 1 over 2. Let's get our LCD. So one of my denominators is X, one is 0.5 times X, and the other is 2. So the LCD is going to have 0.5 and X and 2. So 0.5 times X times 2 is my LCD, which actually works out just to be X because 0.5 times 2 is 1. But I'm going to go ahead and do times 0.5 times X times 2. So 0.5 times X times 2 over 1 times 1 over X plus 0.5 times X times 2 over 1 times 1 over 0.5X equals 0.5 times X times 2 over 1 times 1/2. Then let's cancel out what we can. In that first chunk, I can cancel out the X's. So I'm left with 0.5 times 2 times 1, which is 1. In the second chunk, I can cancel off the 0.5 and the X. So the 0.5 and the X, which leaves me with 2 times 1, so 2, equals, on the right side, I can cancel off the 2's, and I'm left with 0.5X. So the equation I'm looking at is 3 equals 0.5X. And then to solve that, I could either divide both sides by 0.5, or I could multiply both sides by 2. Either way, we are going to get the same answer, that X would be 6. So the question asked how long would it take each printer working alone to do the job. So one of the printers takes 6 hours. The other one is twice as fast. So the other one takes 0.5x. So if x is 6, then 0.5x would be 0.5 times 6, which would be 3. So one takes 6 hours and the other takes 3 hours. I think I'm going to stop here for the moment and then make a second video for equations with radicals. That way you have a little bit shorter for each video to watch.